Hello everyone, my name is Dr. Asan Kumar. I am Assistant Professor in the Department of Electronics and Communication Engineering, SR University, Warangal. So, so, so in that conductor, semiconductor and insulator, we have also another type of material that is magnetic materials. These materials respond to the magnetic field. They are classified into ferromagnetic, paramagnetic, diamagnetic materials. Magnetic material used in transformer, inductor and memory devices. So another type is optical material. These material interact with the light. So they are used in LED, laser, optical fiber and photo detector. Their properties depend upon the band gap energy and refractive index. So another modern that is another modern material that is advanced and smart materials. This includes nanomaterial, graphene, perovskite, memister materials. These are used to make a flexible electronics neuromorphic systems and next generation device. Like that nowadays they are flexible solar cells are available that is made by copper, indium, gallium arsenides. So material are classified based on the electric conductivity, magnetic behavior, optical response, and functional properties. For understanding the material classification that helps to engineering choose the right material for designing efficient and reliable electronics device. Material is Next material is insulators. So insulator is basically used to insulate the basically this is non-conducting materials so that they can't allow to conduct pass the electricity. Basically that is example of a insulator is rubber and plastics. So so let us in detail, conductor are material that allow the current flow easily through them. This is happen because of conductor have large number of free electron. These free electron move uh, easily uh, when the external voltage is applied, creating electric currents. So what make a material a conductor? How to make a material conductors? In atoms, electron revolves around the nucleus in different energy levels. In a conductor material, especially metal, the outermost electron are loosely bonds. These electrons can move freely inside the materials. Because of this free movement of electron, conductor have very low electric resistance, means that conductor is very less resistance. So example of conductor, some common example of conductor is copper, aluminum, silver, gold, and iron. Among of these, copper is widely used electric wiring because of it has conductivity is affordable. Silver has even higher conductivity than copper, but it is expensive, so it is used only for a special application. So properties of conductors. Let Now let us understand some important properties of conductors. That is, first property is high electrical conductivity, low resistivity, very good conductivities, and good thermal conductivities, and low melting point and boiling temperatures. So they can save easily. Most of conductor are metals and they also conduct heat efficiently. So type of conductor can be classified into metallic conductor such as a copper and aluminum where current flow due to the free electrons. Electrolytic conductors such as salt, water, where current flow due to the movement of ions. Application of conductor. Conductor are used in many applications including electric wiring, power transmission line, printed circuit boards, connector and switches, transformer winding. Without conductor, modern electronics and electrical system would not be function. So next is semiconductor. Semiconductor is a very important material for making any electronics device. So semiconductor are a material whose electric conductivity lies between conductor and insulator. They do not conduct electricity as easily as a metals, but they are not completely insulated either. What make semiconductor especially is that there are conductivity can be controls. By using different material in a semiconductor, we can control the conductivity of semiconductor materials. So, what is semiconductor? Is a semiconductor the number of free charge carrier is moderate. Means compared to conductor, in the conductor number of free charge carriers is very high, and in the semiconductor number of free charge carrier is moderate at absolute temperature. They behave like insulator, but if room temperature, some electrons gain enough energy to move into the conduction band and carry a current. This behavior is explained using energy band theory. Semiconductors have a small energy band gap called the band gap between the valence band and conduction band. Because this gap is a small, electron can jump to the conduction band when energy is supplied. So, example of semiconductor, some common materials are silicon, germanium, gallium arsenide, that is two material, gallium and arsenide, it's a composite material. Among of these, silicon is mostly used in material in electronics device because it's embedded, stable, suitable for fabrication process. So next type of semiconductors is mainly classified in two types, that is intrinsic semiconductor. This and another is uh, extrinsic semiconductor. First, what is intrinsic semiconductor? These are pure semiconductor without any impurities. The number of electrons is equal to the number of holes. So extrinsic semiconductor, these are doped semiconductor. A small amount of impurity is added to improve the conductivity. If we add a pentavalent impurities, it is because of n-type semiconductor. If we add a trivalent impurities, it is because of p-type semiconductor. Doping is a key process that is making semiconductor device possible. Important properties of semiconductor have several important properties: moderate electric conductivities, a small band gap energy like that 1.1 electron volts, conductivity increase with the temperature, ability to control the current flow. This temperature behavior is opposite to metals, where resistance increases with the temperatures. So, application of semiconductor are the foundation of modern electronics. They are used in diodes, transistor, integrated circuits, solar cell, LEDs, microprocessor. So without semiconductor, computer, smartphone and communication device would not exist. So next is, so here we can see that there are several materials, semiconductor material, that is silicon, germanium, gallium arsenide, gallium phosphide. So these are the so these are the semiconductor material. There are two types. One is compound semiconductor and normal semiconductor. So compound semiconductor material is a combination of two materials that is called compound semiconductor materials. Another is insulators. So insulator are a materials do not allow electric current to flow easily through them. So, unlike conductor, insulator have very few free charge carrier because they offer very high resistance to flow electricity. So, why do insulator not conducts? To understand this, let us look the atomic structures. In an insulator, the electrons are tightly bonds. So, their atoms, the energy band gap between valence band and conduction band is very larger. This larger band gap prevents electrons from moving freely even at room temperatures. As a result, electric current can't pass easily through the insulator materials. Example like rubber, glass, plastic, wood, mica, ceramic. These materials are widely used in electrical and electronic systems for safety and protection purpose. Properties of insulator is very high electric resistance compared to the semiconductor and conductors. Next is very low electric conductivities because of very less free number of electrons. So free number of electrons is high in any materials, that is a conductors. If moderate free electrons, that is called a semiconductor, and free very low, and that is called insulators. So high dielectric strengths, good thermal and chemical stability. So ability to withstand high voltage without breakdown. Because of these properties, insulators are essential in electric systems. So type of insulator can be classified into different based on their application. Solid insulators such as a plastic and ceramics. Liquid insulator such as a transformer wire. Gaseous insulator such as air, sulfur, hexafluorides. Each type is used depending on the required voltage level and applications. Next, application of insulator material, that is covering electric wire, supporting transmission line, insulating transformer component, printing circuit boards, capacitor as a dielectric materials. Without insulator, electric system would be unsafe and insufficient. So next, so we can see that there are three pictures. That is, first one is energy band gap diagram of insulator. So in that energy band diagram, we can see that the band gap of insulator is very larger. So approx the band gap is like 10 electron volts. In next second figures, energy band gap of conductor. So that in that figure we see like that conduction band and valence band energy are overlap. In third picture, that is energy band of insulators. So energy band of insulator is very small energy band gap, like semiconductor, like that is 1.1 electron volts. So next is difference between conductors, insulator and semiconductor according to their properties. So next is comparison between conductor, semiconductor and insulators. So according to their parameter, that is differences. First is definition. A material for conductor, a material that allow electric current to pass through very easily, that is called conductor. And semiconductor, a material that has conductivity between the conductor and insulator, that is semiconductor. Insulator material do not have to allow the electric current to pass through them, that is called insulators. So according to the energy band gap, for conductor there is no energy band gap between the conduction band and valence band. So, so, so that conduction band and valence band overlap. For semiconductor, a small energy band gap approx 1 electron volt. So energy band gap is represented by electron volts. So and insulator very large energy band gap like that 10 to 15 electrons volts. So next parameter is conductivities. For a conductor, very high conductivities, that is 10 raised to power by same mho by meters. And semiconductor, intermediate conductivities, that is 10 raised to power minus 7 to 10 raised to power 13. And insulator, very low conductivity, that is order of 10 raised to power 13. Next parameters is resistivity. For conductor is low resistivity, semiconductor intermediate resistivity, and insulator very high resistivities. Valence electrons in outermost shell is less than 4 for a conductors. Valence electron for semiconductor is 4 and insulator more than 4. So manufacturing, next manufacturers, in the manufacturing of a solid state electronics device like IC, diode, transistor, used for providing insulation, electric and electronics device. And next is insulator for use for only for insulating material. Example for material like metal is silver. Silver is a best conductivities of conductor. Gold, copper, aluminum, etc. For example of semiconductor is a silicon, germanium, gallium arsenide, gallium nitride, gallium phosphide. So are the example of semiconductor. Insulator is plastic, mica, wood, rubber are the example of the insulators. Semiconductors. As we know, semiconductor are materials whose conductivity lies between the conductor and insulator. Pure semiconductor like silicon, germanium are called intrinsic semiconductor, but in their pure form, their conductivity is quite low. So, motive is to improve the conductivity for making any electronics device. To improve their conductivity, we add very small amount of impurities. This process is called doping. If you add some impurities in the pure semiconductors, that process called doping and the resulting material is known as a extrinsic semiconductors. So we can say like that extrinsic semiconductor is a pure semiconductor, so that is silicon and germanium. What is extrinsic semiconductor? Extrinsic semiconductor, a semiconductor whose electric properties are modified by internally adding the impurities atoms. Even a teeny amount of impurities means a small amount of impurities, sometimes one atom in a millions, can increase the conductivities. Doping help us control the number of charge carriers, the types of charge carriers, the overall electric behavior of the materials. This control conductivity is the foundation of all modern electronics devices. So type of extrinsic semiconductor, that is mainly two types. One is A-type semiconductor material, means that you have to add some impurities, that is in pure semiconductor, then made of N-type and P-type semiconductor. So what type of impurity you add in that extrinsic semiconductor to make a N-type and P-types? So pentavalent and trivalent impurities you have to add in pure semiconductor, then made then semiconductor is known as N-type and P-type semiconductor. In a N-type semiconductor, we add a pentavalent impurities to the pure silicon or germanium. That pentavalent atoms have 5 valence electrons. So that atom donates 1 electrons to neighbor atoms. Example is phosphorus, arsenic, and antimony. When a pentavalent atom is replaced, a silicon atoms in a crystal lattice for of its electrons for covalent bond with neighbor atoms, but the fifth electron as a free. This extra free electron increase the conductivity of N-type semiconductor. In N-type materials, electrons are the majority charge carriers. Holes are minority charge carriers. Means in N-type semiconductors, electrons are maximum compared to holes. So that maximum electron is known as majority charge carriers, and minimum holes is name is called minority charge carrier. Because of electron carry negative charge, it's called the N-type semiconductor. Because of N is majority present in N-type semiconductor, so you can say that. So we can say that that is N-type semiconductor. Next is P-type semiconductor. A P-type semiconductor, we add trivalent impurities. Trivalent atoms have 3 valence electrons. So 3 valence electrons example included boron, aluminums, galliums. When a trivalent atom replaces a silicon atoms, its form 3 covalent bond but lack 1 electron to complete the 4th bonds. So the missing electron create a holes, and holes we have like positive charge carrier In p-type materials, holes are majority carriers and electrons are minority carriers. But in that opposite, for n-type semiconductors, holes are minority charge carrier and electrons are majority charge carriers in n-type. But p-type, holes are majority carriers and electrons are minority charge carrier. Because of holes are positively charged, it is called p-type semiconductor. Energy band explanations in ex, extrinsic semiconductor, doping introduce new energy level inside the band gap. In a n-type material, donor energy level are created near the conduction band, but in p-type material, acceptor energy level created near the valence band. These energy levels make it easier for electrons to move, which increase the conductivity. So, importance of extrinsic semiconductor. Extrinsic semiconductors are extremely important because they allow control the conductivity by doping process. They form the basis of p-n junction. They are used to manufacture diode, transistor and integrated circuit. They enable amplification and switching operations. Without extrinsic semiconductor, modern electronics such as computer, mobile phone and communication system would not exist. So, thank you for watching my video.